Here in this video, we're going to talk about how to find the equation of a quadratic relation in factored form when we know the x-intercepts. So on the screen here, I'm showing you in Desmos what factored form is. It's called factored form. We have an expression that's factored on the right-hand side. So I've got it in function notation, f of x equals a, and then in brackets x minus r, and brackets x minus s. And so I've broken the quadratic equation apart into these three factors. And so factored form is great. It allows us to find the x-intercepts really quickly. And the x-intercepts are when the function is zero. That's why we call it the zeros. So the function is zero when x equals r or when x equals s. So factored form allows us to find the zeros really quickly. You have to flip the signs of r and s. So for example, if the x-intercepts were positive 2 and negative 4, this would be my equation. So I can show you here that I've got x-intercepts at negative 4, 0, and positive 2, 0. So I'm just flipping the signs of the numbers in the brackets. Now, it turns out that there are infinite parabolas that have these x-intercepts. So, some of them are very tall and skinny. I'll kind of zoom out so you can see these. Some of them are tall and skinny. Some of them are wider. Some of them open up, some of them open down. So they're actually infinite parabolas that I can draw through those same intercepts. So we call that all a family of parabolas. So this a value determines the direction of opening, determines how stretched or compressed the parabola is, but all of these parabolas are part of this same family. So on our note, this first question is saying, find the equation in factored form. So right away, we're thinking y equals a, x minus r, x minus s. And I know the x-intercepts are 4 and negative 2. So I just want to think to myself, okay, I want to flip those signs and then put those roots in the bracket. So the equation is going to be y equals a, x minus 4, x plus 2. And this isn't one parabola, this is a whole family of parabolas. Every different a value is going to determine a different shape, but all of these parabolas are going to have the same x-intercepts when this bracket is 0, so when x is 4, or when this bracket is 0, when x is negative 2. So if we know the x-intercepts, we know the family of parabola. But to find a specific parabola, we just need a little bit more information. So I'm going to flip back to Desmos. We can take a look here in this diagram. There are infinite parabolas that share these two x-intercepts. So again, at 2, 0, negative 4, 0, there are infinite parabolas that share those x-intercepts. But once I know any other point in the parabola, let's say the point 1, 6, just any other random point, so that's that purple point here, there's only one parabola that goes through those green x-intercepts and also goes through that purple point. There's only exactly one parabola, and I can kind of find it by playing around a little bit with Desmos. There's only one parabola, looks like it's right there, that goes through the purple point. So that's what we're going to do algebraically in our lesson, is that if I know both x-intercepts in any other point, I can find the equation of the parabola. So I'm just going to do a couple examples like that. We're going to start with kind of our target, which is this a, x minus r, x minus s. And the first thing I'm going to do is I'm going to put in my two zeros, remembering to flip the sign. So I have y equals a, x minus 2, x plus 2. So I put in my two roots. Now I still need to figure out, well, what's the a value of this parabola? So to solve for a, all I need to know is any other random point. So in this case, I know the point 0, 3, and like any point, it is an x-coordinate and a y-coordinate. So to solve for the a value, I can plug in 0 for any place I see x, and I can plug in 3 for any place I see y. And so now I have an equation that I can solve to find a. So I'm just going to follow BEDMAS. I have 3 equals a times negative 2 times 2. A times negative 2 times 2, well, that's going to be negative 4 times a. So we write that as negative 4a. And then all I need to do to solve for a is divide both sides by negative 4. So a equals negative 3/4. And so our parabola in factored form is going to equal y equals negative 3 over 4. X minus 2, x plus 2. So I've got an equation of a parabola now. Like any equation of any relationship or function, it just links x and y. And I've found values for all of our parameters, for a, for r, and for s. Just to kind of show you what we've done, I'm going to flip back over one last time to Desmos. So this problem told us right away that we had to find a parabola that had x-intercepts at 2 and negative 2. That's the first thing we knew. Maybe I'll zoom in. And we were also told that this parabola went through the point 0, 3. So with algebra, the first thing we figured out is, okay, what goes in those brackets? So I've got x minus 2x plus 2. And then we algebraically solve for a. We found that a was negative 3/4. And sure enough, that's the only parabola that goes through those zeros and also that point. So to find the equation of a parabola, all we need to know are the two x-intercepts and any other point. Now to finish this question, they want the parabola in standard form, and so far all we have is factored form. So standard form means I've got no brackets, so I just need to expand. So I'm going to FOIL first. So I've got x squared plus 2x minus 2x minus 4. I can collect those middle two, and in fact those add to 0. 2x minus 2x is 0, so I've got x squared minus 4. And then I can distribute the negative 3/4. So I have negative 3/4 times x squared, and then negative times negative is positive. 3/4 of 4 is just 3. So now I've got an equation in standard form. So that's the idea of our lesson today. If I know two roots or two zeros, and I know any other point, that's enough to find a factored form equation of a parabola. And then by FOIL, by expanding and simplifying, I can get that parabola in standard form. We'll just do one more example, one more little concept of what to do when we have some fractional roots. So I've got two roots or two x-intercepts that are x equals 1/3 and also x equals negative 1/2. So I've got to figure out now, I want to have my equation as y equals, I'm going to have to find an a value, and then I'm going to have two brackets, and when either of those brackets are 0, then I'm at my root. So I'm just going to rearrange this equation for x so that it equals 0. So I'm going to multiply both sides by 3. I get 3x equal 1. And then when I move the 1 over, I have 3x minus 1 equals 0. So that's going to be my first bracket. I have 3x minus 1. So we're going backwards. If I'd factored, I would have solved it by saying, okay, x equals 1/3. Here I know x is 1/3, and I'm just rearranging into a form that I can put into my bracket. Same thing here. I can multiply both sides by 2. I have 2x equals negative 1. So 2x plus 1 is equal to 0. I'm going to have 2x plus 1 in my second bracket. We're going the opposite direction of what we've done earlier in the unit, where I can look at a quadratic equation that's in factored form, and I can say, okay, the roots here are negative 1/2 and positive 1/3, because that makes each bracket equal to 0. Now, same thing, I want to find out the a value. That's the last thing I need to know, and I can use any other random point. So every point has an x and a y, so I can plug negative 7 in for y, and I can plug positive 1 in for x. And then again, I'm going to follow BEDMAS to solve. In my first bracket, I have positive 2. In my second bracket, I have 3. If I multiply those all together, let me just move my camera up the page. I have negative 7 equals 6a. So a equals negative 7/6. And so again, once I've done all my work to solve for a, I can write out the equation in factored form. So I've got my a value, and then I have my two roots. So this is the equation in factored form of the only parabola that has zeros of 1/3, negative 1/2, and also goes through this other point 1 and negative 7. So that's kind of our lesson or our concept today that we went over in this video. It's how to find an equation in factored form when I know both zeros and any other random point in the parabola. So let me know if you have any questions. Feel free to send me an email or drop a comment below. Okay, thanks for watching.